Hey guys, I'm Nick and welcome back to the new tutorial. So today we are creating kinda multiplication in bullet solver with RBDs and all that great stuff that can add a lot of commercial value to your animations. And actually some time ago, and yeah, this tutorial, it actually was planned as like first tutorial of this year, but this topic wasn't that easy as I thought, but then I found a solution how to make it like beginner friendly, right? We don't want to mess with like prim intrinsics and backed RBDs and all that kind of stuff. But yeah, initially, Jonathan Lamanant asked about this particular example by Tavo Studio, like this little thingy with where it begins. Hey, like like right here, where there's a bullet solver, it sees all the intersections here, it tries to solve it, and yeah, then we have this swirly motion kicking it in and a lot of RBD instances, all these face wash bottles spinning around, and then I assume the RBD gets turned off or the collisions got turned off and it's getting sucked into the one bottle again with a bit of distortion there and obviously a lot of intersections. But anyhow, here we are in Houdini and let's get creating this stuff. A few things we should prepare. So I think one of the most important things here would be either camera, because we are using orthographic camera for this scene, or yeah, let's set up the camera right now because I kinda wanna align the things in the scene based on where we will be looking with our camera. So I know that my box, the collider box, should be around like 5 by 5 by 5, so it's not that big, but still. And now I wanna drop my camera. I'm doing this for Instagram Reels, so definitely we want to go with 1080 by 1920, and yeah, projection should be orthographic. Now if we check the camera, you can see it's cutting out some parts of my mesh. Not sure why it is. I assume we want to go and check far clipping and near clipping. And far clipping, let's set it to be like really big value, and near clipping, let's try at 0, and still we have a bit of clipping here. And pressing H actually resolved the problem, and yeah, we are pretty much there. I just want to be sure that my ortho width, want to set it around like 9 or 10. I think it's a good balance between the empty space in the scene and our kind of center object. And then for the transform, I actually like to kind of zero out or get these values in the rotation of the camera to be some sort of, you know, kind of default constant value. So 405, I assume that's just 45 degrees, right? So 360 plus 45 will be 405. And this translation here, so it should be equal on both sides for X and Z. So 13, 13, 13. Here I see maybe 11. And then this rotation on X is actually like how the perspective is tilting like on the x-axis. But I think we can probably work with this one, and then we just will just tilt everything down. So yeah, camera is ready. Just for now, we can get back to our perspective view, our usual view, right? So I know this box, it will be our collider, right? So let's keep that box. But essentially what we want is to add a file with the bolts and nuts that we have. I will be using just the nut model, and it's the one from the GrabCAD. Sudhir Gill is the author of this model. I wasn't able to use the files provided here, so I asked my friend to open it up in Cinema 4D. We also remeshed these files, so let me show you how it looks right now. So we go to the file. Of course, we want to save this project. That's done. And then in the resources, you'll find our NUT-FBX, which will be pretty big. Yeah, definitely want to scale it down. Right now, it's around like bordering to heck a lot of meters, right? So What I want to go with is just a simple transform and move it into the center of my scene. So move to centroid for this transform, and then another transform. I want to scale it down pretty drastically, so it should be at 0.001 or maybe 0.003, and it's gone. Let's press H again, and here is pretty obvious that these UVs will cause a lot of problems for us, so we gonna drop lapse auto UVs or any sort of UV and wrapper, to be honest. And then I maybe wanna rotate it, but maybe we can do that later. Just right now I wanna assemble it, creating packed primitives, because RBDs work with packed primitives. And then I wanna drop a null and call it out nut. Cool. Let's check how it looks in our camera. Yeah, maybe just a bit of rotation. Like what I used in my example was, let's drop a transform here before the assemble. It was like 21.125 on X, minus 15.398 on Y, and 12.6502 on Z axis. So was rotated like this. And yeah, let's drop a dot network right now. Here we probably, this setup will be pretty short, so yeah, I don't think that we actually need to drop the outnet here. We can just assemble, plug that assemble to the DOP network, and then use first context geometry in the DOP network. So yeah, let's begin setting it up. What I want to do here is rigid body solver connected to the out, and then packed RBD packed object, and connected to the left input of the rigid body solver. For this initial object type, I want to set create active objects, but geometry source should be first context geometry. Here we have our nut. Let me just quickly test by adding the gravity here. Boom, it falls down. Awesome, amazing, very cool. And right now, obviously removing this gravity because we don't need it. For the bullet data in my RBD packed object, I don't need any sleeping, I don't need initial overlap, and in physical, I don't need computer center of mass, and hard pivot from point position, and compute mass. Maybe let's check how it will be with the inherit pivot from point position, because I remember I removed that in my kind of original setup. So this is very basic rigid body solver setup, right? We can plug any sort of forces. For example, let's plug pop wind into the post solve amplitude 1, and let's just see, we have the pop wind influencing our RBD packed object, and pop wind is essentially a microsolver, so that means that we can add any sort of solvers to both of these two inputs. And I want to add my sub-solver into the pre-solve connection of the rigid body solver. Oh, maybe let's just briefly touch rigid body solver, because I know that if we set the sleeping time to 2, it probably won't work. So let's set the sleeping time to 0. Number of substeps, maybe like something like 30. Ensure islands are independent should be set to no, 0. And constraint solver, I want to keep that on islands. Split impulse, let's try with these values, maybe they will work, maybe we will need to adjust them. But essentially going into the sub-solver, so anything that you pass between these two will be in your simulation. So if I set my color here, wanna set it to be red, you can see our nut now is red. So everything is, it's basically the chain that will be executed every timestamp or frame. I'm not sure about that, but this will be executed each time the solver goes through, and I think it's each frame. So inside my sub-solver, there are a few things that I can do. I can add a merge and I can add a switch. And here in my switch, I want to tell that I want to kind of inject another geometry every, in my case, 15 frames. So $FF modulo 15 equals 0. So every 15, 30, 45, and so on frames, I will be using this connection to inject additional geometry into my simulation. I can do it very easy, so just dropping object merge and connecting that to the merge and here I want to select my assemble. So let's go to the subsolver again, and yep, connect assemble here. I'm not sure if it will work properly right now because this setup is not finished, but I just want to show you how it works. So here we are injecting again and again. We are adding that one nut right in the center. So yeah, it basically looks like it's spawning, right? Basically, this already works correctly, but few things I want to add just to be sure that everything will work correctly is I want to drop the attribute wrangle after my merge, and oh, not the attribute blur, sorry, attribute wrangle, right? After my merge, I want to set add ID to be -1. It will force the solver to recalculate all the RBD attributes, RBD constraints, RBD collisions for all of these nuts. And then I want to also force it to recompute all the collisions and intersections by saying I at found underscore overlap equals 1. So this will force the solver to actually try and like solve all of these collisions like 100%, because we will trap all of these nuts into the box. So we really want to be sure that we don't have any colliding geometry here. But adding one by one, it's kind of pretty boring, I would say. I want to do something better. I want to add more and more and more nuts to this scene. So we can do that using the for each number, like a loop, right? So this is our for each number, and I want to place it right here, and this will be connected to our merge. Let's pull everything a bit lower so we have some space for our for each loop here. So I want to drop a merge here in my for each loop, and each time I want to merge in my assemble. So here you will see that I have 10 packed primitives because this executes 10 times. If you want lower, you can set the iterations to be like 5, okay? So let me play it right now just to see how it actually goes. Boom, 5, boom, 5. Yeah, that's cool. So it works. What if I want to influence how many of these I actually want to be spawned each kind of spawn time? So what I can do here is go to the for each end, and in these iterations, I can write that I want one iteration plus the result of current frame divided by 15. So with each set of, so at frame 15 we will spawn 2 of them, at frame 30 we will spawn 3 of them, at frame 45 we will spawn 4, and so on and so on. So let's check how it looks. Maybe we should disable and enable my stop geometry just to refresh the cache here, but essentially 1, or actually 2 of them, then 3 of them, and should be 4 of them. Cool. Yeah, that sounds good. And this already looks kind of cool, especially if here in the rigid body solver we can add, I don't know, all types of stuff. Maybe we can add pop attract and see how it will perform for scale set to 10. Yeah, now you can see that they all will try to stay together as hard as possible. I mean, for scale at 100, let's check. Boom. Yeah, they are really struggling to keep up. But you can chain any sort of forces here. Just one thing that I want to add is my collider, and this was really tricky. So pay attention. We want to drop the merge down here and add our static object. So this merge is here, static object goes into the merge. Be sure that static object is on the left side, rigid body solver on the right side. For my static object, and here's the deal, I have my box right, so let me just quickly add null here and call it out box, and this will be in my subpass here for my collider. So I want to use the object transform and create the active object. I want to disable any bounce and bounce forward. For my friction, I also want to go with 0.1 and the number friction scale at 0.1 because I want to give the ability of kind of these nuts to rearrange themselves. I want to go with use volume collisions. And here I want to go with volume sample and division method by size. I want to invert the sign and then go to the bullet data. And this, I think, was the trickiest part, because I want to set this convex hull to be actually concave. And now I think all of these things should work properly. So yeah, cool. We have the collisions work, everything works. It's awesome. But considering that our collider I understand it's kind of like 2 times bigger than our one of our nut, and we are spawning hell a lot of them, so we will need to adjust the p-scale of each kind of iteration. So let's go into the subsolver again, and here after merge I wanna add another attribute wrangle, and in this one I will be manipulating the p-scale, and because these packed objects are actually represented by points, I can influence the scale of the object by p-scale that is usually used as a scale of the particle or grain or whatever. Oh, but actually it should not be there, it should be here after our for each. And here I want to write down that p-scale will be equal, like our highest value, which is 1, minus this frame number divided by 15. And 15 again, it's our step, right? We can like write down somewhere, we're gonna add a null with this kind of step control, and then just update that number there. But just bear in mind that for now we are doing this injection every 15 frames, so everything is going to happen in that step of 15 frames. So here we have the modulo of 15, then in our for each we have 15, and then here we have also this 15, and I wanna then multiply this result of our frame divided by 15, because I mean, a frame 15 divided by 15 will be 1, and 1 minus 1 will be 0, so p-scale will be 0. It doesn't make sense, right? So I want to go with 0.08 as my kind of coefficient multiplier, and then let's check if it works. So let's play the simulation, and oh, I see, we have our puppet tracked, I think, here somewhere, or nope. Why? Or yeah, it's not the puppet tracked, it's the static object. Yeah, let me just disable it for now, and let's see how they actually decrease in size. Boom. Yeah, they are becoming smaller and smaller, and eventually they will come to the p-scale 0. Just check where you want the p-scale division to stop, but we are getting pretty close to 0. But look at them, these tiny little bits, they will be looking very cool in that box collider. Again, what I want to add here would be orient. I want to randomize that by PT number. Let's check how it looks. Yeah, not that much of a difference. Maybe we should uncheck this inherit pivot point from the central object. Yeah, I'm not sure if that orient actually works. It might be something that should be adjusted in the prim intrinsic space. But right now, if I enable the static object and just simulate a few frames, I think we are pretty close to the final result. I see that we have enough substeps, so we don't have any intersections, and this this is looking pretty cool. That shape will be eventually filled with all the small, these little nuts. We can help by adding puppet tracked with the force being -100. Maybe even try 200, because I don't know, why not? And yeah, of course, they will now do their best to go to the sides of our box. Not sure if that's the most organic way. Also, maybe what I want to do here is set my geometry representation to concave. Let's save this file right now, because I know that Houdini has some issues with the concave geometries. And yes, I think it became a lot slower. Stepping simulation. Nope. There are some issues. Maybe if we disable the pop attract, so there are not that much forces influencing. Oh no, I gotta escape this stuff. But yeah, I'm not sure if the concave works for the RBD packed object, and nope, it does not. No. I'm so sorry. It was written in the Houdini documentation, by the way. But yeah, we stick with a convex hull, and you can use any sort of geometry. By the way, if you want some more randomness, you can go this way. So let's just drop a sphere. I want this sphere to be somewhat equal to that nut, or maybe even smaller. Let's set it to be a polygon with a frequency of, I don't know, maybe 4. Let's drop another assemble here and connect our sphere to the assemble. And in my DOPNet, I can go into the subsolver, and here in my object merge, I can add another switch. And this switch, I can duplicate my assemble. Of course, I wanna make sure it's all connected properly. And with this, I can point to my assemble too. And for this switch, I don't know, maybe let's try switching the shapes every maybe 30 frames. So $FF modulo 30 equals 0. So let's see how it goes right now. Because here we spawn nuts, here we spawn spheres. And yeah, we see, okay, one sphere went out. I cannot say that we have much influence on this effect. It is kind of simulating a bit randomly every time, so it's a bit back and forth adjusting the parameters. But essentially, yeah, you can add as many object merges as you want here and then just maybe like cycle through them. But with this one, I know that I wanna kind of end the emission at, let's say, 150. So let's add another switch. Let's plug our switch 1 into the switch 2, and let's plug the DOP geometry into our switch 2. And let's make sure our DOP geometry is on the left side and our switch 1 is on the right side. And here I want to say that till the frame 150, so $FF less than 150, we will be using this part of the subsolver, and then I just will be using the straight input from the DOP geometry. So after 150, I'm not using any sort of these nodes here. And yeah, this will work. And if you want the P scale to decrease faster, you can always up this coefficient here in the attribute wrangle. Let's just see. Yeah, they will be losing their P scale faster right now. And still, I want to be able to control or access each iteration. So what I can do here is right in my for each loop, I can go and add attribute wrangle. And with this attribute wrangle, I want to set the parameter, which will be integer, and I want to set it to be the result of frame divided by our step, which is 15. And of course, I want to convert that to integer, right? So now I will have the parameter that is called type, and it will be different for each set of the injected nuts. All right, so yeah, let's just simulate a few frames so we have something to work with in terms of shading, in terms of accessing the type parameter. And for now, you can see that at some frames we have this impact. Yeah, somewhere here you can see this big nut here. I'm not sure why, but it's only in the subsolver. So when you will be checking out your DOP network, of course, you don't want all the objects, you just want the RBD packed object here. Yeah, there is no that large object, it's not there. All is looking correct. Yeah, let's maybe just simulate a few tens of frames and see how they all are distributed in that cube. I think these were the smallest ones that we actually need, so it's frame 120 for us. All right, so now let's go and open geometry spreadsheet after the DOP network. Unfortunately, we are still in the DOP network right now, so we're gonna wanna unpack our objects. So let's drop an unpack. I want to transfer my velocity for the motion blur. I want to transfer my type attribute. Where it was? It's here. Cool. So right now, if I check my unpack and see what attributes I have. I have a lot of points with the type 0, then we have type 1, 2, 3, 4, 5, 6, 7, 8. 8. So we had 8 iterations right now. At 15, at 30, at 45, at 60, at 75, at 90, basically 2 times in 1 second. And now I can access this attribute type, which goes from 0 to 8. I can access that and colorize my points, or actually my objects. So here you can see that they all are a bit different, but maybe, yeah, let's try. Yeah, this works better. So now you can see how they actually are all different. Let's check how they look in our camera. Yeah, and that's basically why I wanted to. Yeah, I think I wanna go with that bottom view. So I wanna rotate this, I think, to something like 15, and then I want to go down on the y-axis, so it's more like this. Let's check again where we are with our box, and yeah, we are looking from this side, and yeah, I think this looks pretty cool. For the coloring, so this is a tricky question, because right now we have 1, 2, 3, 4, 5 5 inputs. We definitely need more, right? So let's just add a bit. And what I want to do is spread them sort of equally. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. This one, yeah, 0.3, 0.4. Yeah, I'm just realigning them so they are all on their places. 0.5, 0.6, 0.7 and 0.8, and then there should be like 0.9 and 1. All right, so now we have like 9 distributed segments, and I want all of them to be either constant. Yeah, constant, because I don't want these iterations to be like similar in color. And we can see, basically, we start with the black color, which is here, right? We can, I don't know, paint it orange. Then after for our first iteration, we have 2 of these, and then we can color them, I don't know, maybe white. And then at the iteration number 3, we spawn these. So I don't know, pick any sort of theme, color palette, and then you can just go and adjust any of these individual colors. Just make sure you're on the right frame, because yeah, they appear as the kind of that injection cycle goes. Let me just copy my colors from my setup that I already done here. So yeah, let's check these. Yep, this is how they look, and yeah, we are pretty much done. I just wanna maybe set up, yeah, materials. We will talk about the materials a bit later, but you have probably seen these little kind of edges here on my grid. So let's talk about them. What I want to do is grab my box and work with that a little bit. So we want to drop the poly wire, which will create wire on our edges, and this is why we're keeping this box very simple, because as you add subdivisions, poly wire will add wires accordingly. In our poly wire, I want to set the wire radius to be 0.05, and divisions, I want to set them to be 7 with like 30 segments, because we wanna cut out or boolean some of these parts. I also want to subdivide it right now to kind of make it a bit smoother, you know, yeah, more organic, and probably like add 2 subdivisions. So after subdivide, I want to drop the boolean, and my subdivide goes into the left input of the boolean, and I want to drop another box that goes into the right input of my boolean. And this boolean, I want to set it to be intersect instead of subtract. And let's just visualize our template here. Let's maybe go into the top view, and let's visualize our box. And this box, we basically want to get it like around here. Size of this box should be 555, like this. And then we want to set the X position to be -2.5, center to be 2.5, and Y and Z actually, I think 2.5. And yeah, let's check how it looks right now. With the boolean enabled, it should yeah, it should perfectly cut out the part of our box. And then we can do the same, absolutely same thing. We can just copy these two, or actually, like, we don't need subdivide. After the subdivide, we can split it to be two booleans. So subdivide here, subdivide into the second boolean. And for this box, I wanna actually go 2.5 minus 2.5 and minus 2.5. So, oh, no. I actually accidentally changed this box here. For this one, 2.5 minus 2.5 and maybe minus 2.5. Yeah, like this. All right, cool. Now we're gonna merge these two booleans into one, and we have these kind of holders for our box. Then yeah, I don't know, I added the glass, and basically the glass is just the box with a few cutouts. So delete, connect box to the delete, and then just check what size you want to delete. So yeah, for me it was looking like that. And then you're gonna merge all of that together. So our color, our merge with the tubes, and then our delete. We merge it all together. Boom. This is what we have. And if we check how it looks from our camera, looks pretty nice. And yeah, that's basically it for the actual setup itself. Let's now go and texture it and set up the lights, and I'll show you how to render that out. So our slide dome is what we will add here. As usual, I'm just using that one HDRI, which is Brown Photo Studio. Saturation set to 0, enable new viewports disabled, environment. Yep, we don't need that HDRI as a background. And yeah, let's set up material network. So drop material network. RS material goes here, connect it to the redshift material, and connect out color to the surface. Copy that one time, copy that second time, copy that third time, and for the third time I want to replace my material with RS standard material actually, and this plug that into the surface. So we will add the background plate, so BG material, tube material, and our glass material. So let's assign these materials, and then we will be just kind of live in Redshift, so you will see how we progress with these materials. So here, material, wanna set it to be the shape material. I don't think that I actually, oh yeah, shape material. So let's go back, Geo1, this material, net shape material, right? So this one will be glass oh no, not the matte net. Just copy the material, drag it over here into the chain with our glass. So glass material here, and this one should be tube material. For the grid, let me just copy the grid for the sake of time. I mean, it's just very simple grid. It's a bit tilted, but yeah, that's basically it. So nothing fancy. This grid should have the material, which should be our BG material, our background material. So yeah, I think we are good. I think we are ready to fire up the redshift. Maybe you want to get slightly lower like that. Oh no. Camera 1 and just slightly lower. Some sort of centered in the frame. And yeah, don't forget to save your project. Let's double check if we have everything set correctly. Tube material, glass material, and shape material. Cool. And now new paint type, redshift, render view. Let's fire it up. And here we are with our nuts. Of course, no color data, no shaders, nothing, just I would say pretty good light. So you can adjust the lights, of course, just by like transforming the R slide dome here, right, in the rotation. But yeah, let's go in and check our shaders. First of all, what I want to do would be the easiest one, right? RS point attribute, out color to the base color, and refresh the render. Now it works. Cool. So maybe let's set up our glass, right? My glass will be super simple. So it's glass that should not be thin walled, and I want to set the roughness to be 0.2. That's basically it. You can add some noises to the roughness map. I don't think that for this stylistic look, we are going to add a lot of like fingerprints or something. It's more like a touchy UI with these colors. So yeah, I think the white and blue. I saw that in IBM animation by Man with Machine. I think that's sort of inspired from that. But yeah, in general, I would say it's a pretty techy color palette here. So yeah, just going with a rough glass here. And for my tube material, I want to go with a preset, set it to be, I don't know, maybe aluminum with a quite dark finish, and roughness at 0.35 would be pretty good, and metal etched into white. And then my background material should be just if we go iron, nope. I mean, yeah, it's just plastic. Absolutely rough plastic. With I want to go with like whiter, like brighter scheme, but let's see how it will work when we work with our shape material. So the main and basically the only reason I'm going with the standard material is I want to use the subsurface scattering. I want to introduce some sort of a kind of, not the jelly look, but some sort of a very, very thinly 3D printed pieces, maybe. I don't know, never 3D printed anything myself, so might be wrong, but base weight to 0 and subsurface weight to 1. Now they are most definitely looking like a very, very, very jelly something. That's not correct. I want to set my radius to be around like this dark gray color from the color picker. Even better if we go with a even darker color like this. I want to introduce the subsurface like just a little bit, just to make it a bit more interesting than just regular plastic, right? And I want to plug this color, particle attribute lookup, I want to plug that into my MS color, which stands for this one. And now we can see the subsurface. Maybe it's even too much. Maybe I want to go with, yeah, a little bit less radius, like this, but we will adjust that. Include mode, maybe all objects, but I don't see much difference actually with the radius. No, I think we can go with only self, and yeah, this color for the radius. Scale is 1, everything else is mostly default. My roughness, maybe I want to set my roughness to be like 0.1, no, 0.2, 0.3 even, 0.3, I think it's good. Of course, you can plug any sort of noises into that one, but I wanna just one noise for my bump map actually. So RS max on noise, bump map, RS bump map here, plug the out color into the texture of the bump map, input here, out bump input, and this obviously is too much. It looks horrible. It looks like, I don't know, something. I want to go with just the FBM noise, and a very important step is to set the source to be UV vertex attribute. Overall scale, I want a pretty small bits of noise. Not sure if we will be able to see them. It's still pretty hard to process all this SSS subsurface scattering, but with my bump map I want to keep it relatively low, like maybe 0.01. Let's increase the max on noise overall scale so we can see better if we actually use the right amount of noise. Let's maybe restart the render because right now I don't see any noise. Effect by object scale unchecked, and yeah, height scale at 0.1 or even 1. I don't see much noise right now, but I think we will see once it's rendered, and that looks too much for me. I still think that we want to go with 0.1 or even 0.05, and overall scale at 0.3, I would say. Be sure to check this out yourself. And yeah, then let's see where we are right now. Looks pretty good. I still maybe would like to add a few more things with the post effects. Want to go with photographic exposure and maybe bump up the saturation a bit. And then in color controls, I want to up the exposure and up the contrast just like a tiny bit, like that. So yeah, I think this looks pretty good. And of course, we want to add motion blur when we will be rendering that out. So let me show you. We want to go to the OBJ for the geo, and here in the Redshift OBJ settings, mesh deformation blur from velocity attribute. Boom. And then now, if you go to the out, I won't be resimulating that. Sorry guys, this tutorial is already pretty long. But what I usually do is set the output to PNG, I don't want to like render EXRs. Don't have much time to comp EXRs. But here, if you switch the redshift to advanced, you will have motion blur. So basically, check these boxes. I usually adjust the end one mouse scroll down, so it was 75.75. I will be using 0.65. And for my global illumination, I go with 10 and 10, both of them brute force. And for my sampling, I usually uncheck automatic sampling, set this to be 0.001, and min samples 128, max samples 1024. And yeah, this is how I basically render all of my stuff, almost all. And turn off this one, and yeah, here we are. So yeah, that's it for today, guys. Really hope you learned something new. With that soap solver, you could do so much cool stuff, and really hope you enjoyed it. Really hope you learned something new, and hope this comes handy for your commercial and personal projects. Also, our live stream will be next week on Thursday. I will let you know about the time, but it will be sometime by day in my time zone, GMT +2. I'll do my best to answer your questions and probably do a few things for the next tutorial, which will be in February. So that's it, and see you next week. Bye!